Hello, guys. I'm George Gonzalez, and I'm obsessed with making games. And today, we are actually going to get into the specifics of networking animations and the foundation and how to start and the things to watch out for. So, this is going to be a very good video for those that want to do multiplayer enemy AI. Okay, so the first thing is I'm going to show you exactly what I'm talking about. I have a build on my headset, and this is right now my game is in VR, but this will apply to any kind of game. And we're using Fusion too. And the main thing that I'm gonna show you is the sync of the animations that it's happening. There still is a small glitch that I'll figure out, but for now, this is really good. And I'll do a recording so you can see the headset at the same time as the editor is. So let me. So these guys are over here in the corner, and what I'm gonna do, we have the blue guy is the leader, and the rest of the group is gonna follow. Okay. Let me get in my headset, and I'm gonna start recording on my headset too, so you could see the sync version. Okay, so here's the recording. I'm gonna follow the guy behind, so you could see the sync. And they stopped, and they're moving now. I'm going behind them. Then I'm gonna try to go ahead of the leader, and they stopped. And then they go, and I'm trying to follow him, the leader. And it should sync up pretty well. You'll see right now the host is my headset. And so we're gonna do another build, another playtest where the headset is the client and the computer is in charge. So let me stop the recording. I'm gonna pause, and then we're gonna start over again. Okay, so what we're gonna do is we're gonna start the game in the computer and the PC, and then I'm gonna join on the headset. And the point of this is to test both the client and the server in the editor, because I can't see right now, I don't have any logs on the headset, but I know it works. But usually what I try to do is make sure I test both scenarios where the headset is the host and the headset is the client. So right now there's no one in here, and I'm about to join. See, so I just joined. So let me get the recording going so you could see what's going on. Okay, and I'm gonna follow the back of the guy right here. They stop and they're about to go, and I'm gonna get in front of the leader. And you'll see, hopefully I'll try to sync up the video so you can see both the headset and the editor running at the same time. And so you can see that they're syncing. The only thing that I want to fix eventually is the little glitch that happens. But that might be minor, and it might not even be visible when we're actually doing behavior stuff. So we're going to go over specifics. And the main point of this tutorial is to help you understand what needs to be networked and the base foundation for expanding. So because when you're making games in general and you need to debug, you want to simplify tasks so that you can understand where the problem is. If you go straight into creating this crazy system, and even when you get to the end, it'll always be crazy because there's a lot of components. You need to be able to understand how to break it down so that you could test small versions of that big code. And especially when you're starting, because when you're starting out, you are small. And so you want to make sure that you test things as you go and save. Right now, I'm in a different branch. And as you develop, you want to save versions of this so you can go back and if you need to. But the main thing is being able to break things into smaller pieces, especially with code and logic. You need to be able to separate things so that you don't go crazy. And the multiplayer is even more so because it can get crazy really fast. So we're in the testing scene, and I'm going to show you what we did. The whole point of this was to figure out what is the least amount of work or code that I need to network this. Okay. And we didn't do that in the last one. Last one, I went in and created new network objects based on the previous one. And this time I said, okay, what if we left the logic all the same? We don't touch it. And can I just like toggle things on and off? And we can. And so this is what we did. We have in here a prefab. And actually, I think we only have 2 or 3 scripts that are networked. But we have these. The only reason we have network versions of these guys, 2, is just for color variation. They didn't need to. It's just that in order to test the leader and whatnot, we just wanted to make sure we knew which one was the guard and which one was the leader. But I think it was off. I don't remember. Anyway, so we have they're both the same. But the idea is we have this network transform. The first thing is the Nav Mesh Agent, and the network transform is the thing that connects. So when we have a client, we need to turn off the nav mesh. We're not going to do any nav mesh agent stuff on the client. This is the host. This not necessarily the host, but the state authority of the enemy will be the one deciding where they go. And it might be nav mesh agent, it might be a star path. You can do whatever you want, but you just need to make sure that is off, and the network transform does the logic for moving the enemy. Okay, and with nav mesh agent, there's one flaw that happened. If you just do this without doing anything and you set destinations, it's not going to work. The nav mesh is going to go a lot slower. And so what we did is we have this network controller. Okay, and this does all the work. This controls the nav mesh agent to make sure that it runs at the right intervals or simulation, so that it can sync up. Because the moment I put the network transform, the nav mesh agent would go really slower than usual. So I was like, I need it to be exact, because we just tested it in single player and it was working fine. And so in order to match that, I'm going to show you that first, because that was the most important thing. Okay, so here we have the network controller. This is the main thing. And we have a network behavior. We have the nav mesh agent, the MPC component. So this is specifically things that we're going to hide later. I'll explain that in a minute. The main thing you need to know is that this guy right here, this is what determines what gets turned on and off based on spawn. So each network solution has a way to determine when something spawns. And that is usually better than if you just do start or awake, because you are not guaranteed that the object is spawned when it starts or awake is called. And that depends per network solution. In Fusion, it doesn't work. You'll get errors because things are not initialized. In this, on spawn, we are guaranteed that this object has been initialized and that there is a network solution that's connecting them. The main thing is in here. In previous episodes, we went over root motion and how we need to remove this update position and rotation so that we could do it ourselves. And in a similar manner, we have to remove that so we can do the motion ourselves. So this helps us say, hey, we're gonna do the update on our end, because there's with a network transform, there's a different update alignment that needs to happen. And so that's what this is. The fixed update network is the simulation is similar to, or it's a parallel version of fixed update, the regular fixed update. So instead of doing it on the nav mesh agent, the position and rotation, we're going to do it ourselves, but we're still grabbing the agent position and transform. So we still have the speed, the position, the rotation, and the position. Like I say, hey, go to the next position and then go to the next rotation. And this right here is what fixes the sync issue. So that's the first thing. This will fix that. So if you don't do anything else but this, it will get you to sync the transform over the network. Okay, so this will help with that. The next few things are, we needed the speed, because the speed is what drives the animation. That's the second part that we needed, because the animation, the walking and running needs to match the speed that the agent's going. Remember, we have those two things that this guy does that. Okay, so it sets the speed for the component. And in here, when we have the speed change, and we've seen this before, we've done it, but I make sure to do it on the same script here. We have just one thing. So one script that basically takes care of all the components for now. Okay, and the main thing that this doesn't take care of is if we do attacks and other animations, right? Because that's when it starts getting complicated. And we're not going to do that right now. This is the foundation, the base. Let me check, make sure there's nothing I missed. So we have the animator, if we have any animation variables that we need to cross. And the only one right now we need is the speed. That's the only thing, because the transform is taking care of the network. Now, if you have a Boolean, that's why behavior trees are so much better than if you did and syncing that over to the animator is what's gonna trigger things. But if you have the behavior tree that does a lot of the logic for moving and determining what happens, you simplify the things that you need to network to the animator. And we'll see that in the future as we build on. But the whole point of this is to build that foundation. With this, I was able to do all the syncing. That's it. We did have some network things for the groups on how we handle groups, but let me show you that in a sec. So in here, so as you see, we have these and the animator. Everything's the same. Okay, we have an animator, the nav mesh agent, the MPC is all the same. The only thing we changed is we moved the Wonder script to this guard AI script. And if we go in here, we have the Wonder script and the group member. And the Wonder script used to have an area, and we decided to just, for the sake of simplicity, because the whole point of this is to say, hey, we're not going to need this area. And so instead of doing that, we're going to do the random destination ourselves right here. All right, so it's the same thing that the area had. except the area was specific, so you could control it in the editor. Um, so that was the only difference, is that we have the Wonder doing its own thing for the area, and then we have a group member script. That again, these are not networked. This is the same as the video. If you were to watch the video that we talked about in the last episode, it's all the same. We set the position. If it's if there's no group, we wander. If the group leader is this NPC, we wander too, because the leader is going to wander, and then everyone else is going to follow the position. And that we go to the group, we get the position from the formation, and the formation is a scriptable object. So the scriptable object will have a bunch of information about what the next point is based on the leader. And so that is pretty straightforward. Everything's the same, single player. But what happens is when we start the game, like I said before, we have, see how it says guard AI? This script gets turned off for the clients. So this does not, so it gets turned off on the client, that's all, because it doesn't need it. And that makes it so that nothing gets called. So if you had Emerald AI, the problem with Emerald AI is that it's all integrated, so you can't just like turn one thing off. But because we are starting from scratch, I can manipulate things to make sure that everything is in here. And the way the videos, I like the videos, it shows you have this NPC component that gets the NPC from the parent. And so you can have these children that function because they look up the NPC. And you can have all your stuff in here that does all the logic, and you can turn it off and on. In Emerald AI, you can't, because it's already set up a certain way. But you can still turn things off and on enable. So you just have to override the start and make sure, instead of doing their start, you do your network start and you disable everything. The problem is that there's so many things to disable that it makes it hard to know. It makes it hard to figure out which. In Emerald AI, the problem is that there's so many things to disable that it makes it hard to know if you caught everything. If that makes sense. Like, did I catch it? And then you just keep going until you fix all the errors. And then you have to go through this process. But it's similar to this idea, is that you turn off everything off in Emerald AI by default, unless you're the master client or the person that spawned the enemy. And then you just make sure you have to sync all the Boolean values for the animations, which is, it could be like 50 to 100 different Booleans, right? And so it gets really hard to do that from the beginning because you haven't even started, right? And the other thing is with Emerald AI. Oh, and the other thing with Emerald AI is that if you change the host or who the master client is, let's say the host leaves and the rest of the people are still there fighting enemies, you need to now switch over this stuff, and you can't just turn it on and off. Like, you have to have that logic for switching over and either deleting the guys or doing other things. And so that's what we're going to go over in the future with these videos, is at the end of everything, I have to make sure that these things work, that these enemies work regardless of who the host is or who the authority is for these, so that it swaps in and out. And how do we save the state of where they're at? Or maybe just reset the state of, like, the moment that the enemies get changed, we reset everything, and that's okay, but they're still in the same position, and we'll look at that when we get there. But this will give you an idea, a foundation. The last thing we want to go over is the group, because if you followed along, you're like, okay, well, there's a group execution creator in, and how do we do that? So basically what I did is I recreated the scripts with a network behavior. We have this create group, and this create group does everything the same. This is just it's like for the editor. It's just in there in the inspector to show you to group things together so they're not everywhere, which is really nice because it parents things and it connects the groups to the game object, right? That is nice. Nothing changed on that. The main thing that has changed is this. We needed to instantiate things, and again, we needed this spawn. So when it starts, instead of doing on start, we do on spawn. When it spawns, we create the random group. It's all the same as before. The only difference is, as you see here, we needed to spawn an NPC prefab, a game object. So in here, we don't have NPCs, we have game objects, but those game objects still have NPCs. So what I did is, instead of doing this, we changed it to this. See how it's pretty much the same. And then we didn't need to do the area thing. Again, that's why we didn't want to dive into area, because it wasn't very important. And then in here, we did the same thing. We have a follower, and we get the NPC. The NPC is needed for the groups because it adds the NPCs to the groups, and it gives you the leader position and whatnot. So we're still keeping the NPC logic. Everything's the same as the previous video, but it's network. And see how simple it is. That's why I iterate sometimes, like, how important that channel is, Sue's Dev, because it helps you build a foundation on animations and behavior trees and how to tackle things in a simple way first, and then expand on it. And if you do that, you can have pretty good and solid foundation for your enemy AI in a multiplayer game. So you can have a great prototype with just some basic animations to start quick. You can do all this in one day. If you look at the videos, it's maybe 10, 20 minutes. It maybe takes you 4 hours. It doesn't matter how, like, if let's say it takes you 4 hours to learn the single player version, and then maybe you're exhausted. But if you have the stamina, 4 hours, and say, I'm just gonna learn the single player version, and then you watch the videos that I created for the network that I did last Monday and this Monday, we are building these, and you have 4 hours to do the multiplayer. It won't take you 4 hours to do the multiplayer version. As you saw on this, if you jump, you don't even have to watch the previous Monday. You just watch the 2 videos, learn it, take 4 hours to really dig it in, make it your own. Whatever animations you need to import, you can watch my videos on importing and setting the right settings, applying those settings, all the things you need from Mixamo. And then you come to this video and you do what I just showed you with the network objects. And you have something within a day. You can test with animations, and you can start seeing things come alive. Even if you need NPC players that move around to make the town feel great, instead of just having random animations. This already feels better. And then in the next Monday, we're gonna go over chasing and what we're trying to plan. So I'm not going to do this follow the leader stuff because that's not in my game. The next week, what we're going to go over is networking, where these monsters are spawned and they patrol. And as they patrol, when they detect you, they'll change to chase, and they'll do a chase. They won't attack you, but they'll chase you, and we'll network that. And then after that, we'll go into attacks and branching and behavior trees and switching and more complex stuff. But everything's going to be single player and then multiplayer. And so that you can do it step by step. So if you want to stop at a certain point, you can, and you just do whatever you need to, or whatever the budget is. That's the idea. And all this content is out there for free. If you like it, please subscribe, like the videos. If you have questions about what you want to see for multiplayer behaviors or solutions that you have a problem with, comment below. If you need one-on-one help, I have Endgame Devs where I help developers one-on-one. We'll see you in the next video.